All right, question 4 says a bug moves along the trajectory described by this vector function r of t, whose components are 3t plus 1, t squared, and e to the t minus 2. Times measured in seconds and distances are measured in meters. Include units in your answers where appropriate. All right, now part A says compute the velocity vector v of t, which as we saw in the last video, that's just r prime of t for the bug. All right, so to do that, right, we can just differentiate component-wise to compute r prime of t. So differentiating 3t plus 1 gives us just 3. Differentiating t squared gives us 2t. And differentiating e to the t minus 2 gives us e to the t minus 2. And notice there the chain rule factor is just 1 because the derivative of t minus 2 is 1. Okay, so that is our velocity vector at any time t. So now for part B, it says compute the velocity and the speed of the bug at t equals 2. Well, there I'm just going to plug t equals 2 in for time and our velocity vector we computed for part A. That's going to give us our velocity at t equals 2, and that's going to be 3, 4, and then e to the 0, which is 1. Okay, so that vector describes our velocity at t equals 2 for the bug. The speed, on the other hand, that's not a vector, right? It's a scalar, and by definition, the speed of an object is the magnitude of its velocity. So in particular, if I want the speed of the bug at t equals 2, I'm going to take the magnitude of this velocity vector 3, 4, 1. Okay, so that's the square root of 3 squared plus 4 squared plus 1 squared, which comes out to be the square root of 26. And here I'm going to include units, and since distances are measured in meters and time is measured in seconds, the speed will have units meters per second. All right, cool. Then for part C, it says compute the unit tangent vector, capital T, at time t equals 2. Well, what's the unit tangent vector? Well, the derivative vector, r prime of t, which is really just the velocity vector, right, we know from the last video, this points in the direction tangential to our curve at r of t in the direction of increasing time, right? So if our bug is, say, moving along this green path from left to right, right, then at this point here, at the head of our position vector, r of t, the derivative vector r prime is going to point in this direction as you see here. All right, so then what's the unit tangent vector? Well, that is going to be the unit vector that points in the same direction as r prime. So there I'm just going to take r prime of t and divide it by its magnitude. All right, so that's going to give us this vector you see here in blue. It's just going to scale down the red derivative vector to give us this unit vector we're calling capital T, the unit tangent vector. So there, right, if I want the unit tangent vector at t equals 2, well, I really just want r prime of t over its magnitude, or in other words, I want the velocity at 2 divided by its magnitude. And I've already computed those up here, right? The velocity vector at t equals 2 is 3, 4, 1, and there's its magnitude. So dividing component-wise, I get the vector 3 over the root of 26, 4 over the root of 26, and 1 over the root of 26 for the unit tangent vector. Okay, great. And then last up is D. It says compute the acceleration vector for the bug. So there, I'm just going to differentiate my velocity vector from part A, which is also the second derivative, right, of r of t. So that's going to give us 0, 2, e to the t minus 2. All right, and that does it for this question. Thanks so much.